Good morning. Today we are going to estimate percentage of copper present in the given brass sample. What is brass? Brass is an alloy. What is alloy? We have alloy, combination of two or more metals or non-metals gives you an alloy. So brass is an alloy of zinc and iron. I mean copper, zinc, right? Copper and zinc. So in that we're going to estimate how much percentage of copper is present. Let us see how it is done. Estimation of copper present in brass is done by iodometric method. So what do you mean by iodometric method? Iodometric method is nothing but a sample is taken. The sample is treated with potassium iodide in a acetic media. When a sample is treated with the potassium iodide in acetic media, the sample liberates equal quantities of iodine. Brass will be treated with a I'll take brass as an example to explain iodometric estimation. So brass will be treated with potassium iodide in acetic media. So what will happen? Brass will liberate equal quantities of iodine. How much amount of copper is present? Equal quantity of iodine will be liberated. So the liberated iodine will be estimated against the liberated iodine will be estimated using starch as an indicator against sodium thiosulfate. By knowing the volume of sodium thiosulfate consumed, we can estimate the percentage of copper present. So iodometry, because by knowing the volume of iodine, amount of iodine liberated, we can estimate whatever is present. That is called as iodometric estimation. As told earlier, brass is an alloy of copper and zinc. It contains mainly 60 to 90% of copper, 20 to 40% of zinc, 0 to 6% of tin, and 2% of iron and lead. Okay, so brass is prepared by dissolving at 10 minimum 1:1 nitric acid. When you take brass sample dissolve nitric acid, you get fumes of oxides of nitrogen. These fumes of oxides of nitrogen are very dangerous. They cause holes in ozone layer also. So instead of that, what do we do is we take, not to prepare the brass sample, we take copper sulfate and give solution. Okay, so let us see how to prepare the copper brass sample. As I told you, so here the copper the brass sample, to the brass sample you're going to add potassium iodide. When potassium iodide is added, you get cuprous iodide and potassium and iodine. So this iodine, if you have 2 Cu, you will get 2 iodine molecules. You have 10, you will get 10 iodine molecules. You have 30, you get 30 iodine molecules. Okay, so equal quantity of iodine will be liberated. That liberated iodine will be titrated against sodium thiosulfate to give you using starch as indicator near the end point. Okay, so by knowing the volume of sodium sulfate consumed, we're going to find out the amount of copper present in the given brass sample. So we're going to, as you know, we have two parts: preparation of standard solution and preparation of estimation. So here standard solution will be given. We're supposed to prepare the brass sample. So earlier we used to weigh the brass sample, dissolve it in the nitric acid, and then used to prepare the brass sample. When you dissolve the brass sample in nitric acid, it will liberate fumes of oxides of nitrogen. These are very hazardous to health, so we cannot inhale that, right? So, and it also damages the environment. Keeping that in our mind, what we're going to do, we're going to take copper sulfate, W grams of copper sulfate in a standard flask. To that we're going to add quarter test tube of sulfuric acid and little amount of crystals and make that solution up to the mark. We're going to take W grams of salt, okay, add little quantity test tube of sulfuric acid, little amount of water, dissolve it and make solution up to the mark. From this solution, we're going to prepare 25 ml of brass solution and estimate how much amount of copper is present. Okay, so here the procedure, first we're going to prepare 25 ml of brass solution to conical flask and add dilute ammonium hydroxide. So we're going to add dilute ammonium hydroxide until you get blue PPT. So why you're adding ammonium hydroxide? Because the brass solution should not contain any acid. In order to remove the acid, we are inorganic acids, so we are going to add ammonium hydroxide. So how will you know the entire inorganic acid is removed? So you know, as here, while preparing brass solution, what did you add? Sulfuric acid, right? So in order to neutralize that, we are going to add what? Ammonium hydroxide. So that is indicated by change in color. The copper sulfate will be light blue in color, this blue in color. So when you add the ammonium hydroxide, it will give you a dark blue, this blue color, your record color. Okay, so when you get this blue color, it indicates that the entire acid present is neutralized. So now, as I told you, this is a iodometric method. The medium should be acidic. How to make the medium acidic? We're going to add acetic acid. So how will you know the medium is acetic or not? We're going to add acetic acid dropwise until dark blue will become once again the light blue in color. So why? You can ask a question. So already the medium was acidic, sulfuric acid was present, but we have neutralized it and again we are adding acetic acid in order to make the medium acidic. Why? Why? Because the inorganic acid present is already present, right? Sulfuric acid is present. In presence of inorganic acid, when you add potassium iodide, the potassium iodide will get oxidized to iodic acid. It will not liberate iodine. In order to prevent that, we're going to neutralize the inorganic acid. Those are strong acids. Later, make the medium acidic by adding the organic acid. Okay. So then you're going to add potassium. Then you're going to titrate the solution. Okay. Once you get the titrate the solution until once you get light blue color, we're going to add 1 test tube of potassium iodide. As soon as you have potassium iodide, you're supposed to start the titration. So before starting the titration, you're supposed to fill the burette with sodium thiosulfate and keep it ready. As soon as you have potassium iodide, the reaction is very spontaneous. The copper will react. The copper present in the solution reacts with potassium iodide and liberates iodine. So the liberated iodine should not escape in the atmosphere. Therefore, as soon as you have potassium iodide, you're supposed to titrate with the titrant. So until when you're supposed to titrate? Until you get straw yellow color. Once we get the straw yellow color, we're going to add few drops of starch indicator and titrate. When you add starch indicator, you'll get dirty blue color. And titrate until you get milky white color, permanent milky white color, which is due to the formation of cuprous iodide. So once we get milky white color, we're going to note down the volume of Na2H2O3 rundown. By knowing the volume of Na2H2O3 rundown, we can calculate the copper present in the given brass solution. So this is how you're going to calculate. Weight of brass is W grams. Normality, we're going to take it as 0.1 or we're going to change it to 1 normal. So if 1000 cc of 1 normal sodium sulfate is equivalent to 63.54 grams of copper. If 1 cc of normal is equal to 0.06. So if it is 1 normal, if it is 63, then you divide by 1000, we get it as 0.06354. Therefore, for XCC means how much? How much volume it is consumed, titration value, right? XCC of 0.1 normal sodium thiosulfate is equal to X into 0.1 into 0.06354. That is going to call it as A grams. So therefore, percentage of copper in brass is A into 100 divided by W. W is weight of brass sample taken. This is how we are going to calculate the percentage of brass present in the given sample. So there is a small demo here how to perform the experiment. You can have a look over here. Okay.
Given standard sodium thiosulfate solution. You don't have to prepare standard solution here. Standard solution will be given to you. So fill the burette with the standard sodium thiosulfate solution. Second step is you have to prepare the standard copper sulfate solution here. For that you have to weigh the given copper sulfate crystals, and for that you have to add few drops of H2SO4. Then make up the solution accurately up to the mark. Mix it well and keep. Understood, right? You have to weigh the given copper sulfate crystals into a cleanly washed 250 ml volumetric flask. Add few drops of sulfuric acid to dissolve the crystals and make up the solution accurately up to the mark. Mix it well. This is our required standard copper solution. This we need to pipette out now. Okay, now we have to pipette out this standard solution. 25 ml into our cleanly washed 250 ml conical flask. Pipette out accurately 25 ml. So it's exactly 25 ml. Transfer to conical flask. stems to the bottom of the conical flask. Now next step is, see, we have taken 25 ml of the prepared copper sulfate solution. Now we should add dropwise ammonium hydroxide until you get a dark blue coloration. Okay, we are adding ammonium hydroxide to remove the mineral acid if it is present, because in the synthesis of the solution, when we were preparing the standard solution of copper sulfate, we have added a H2SO4. So to remove the mineral acid present, we are adding ammonium hydroxide. Okay, keep on adding ammonium hydroxide dropwise until you get a dark blue coloration. Keep on adding ammonium hydroxide until you get dark blue color. You are adding ammonium hydroxide to remove the mineral acid present in the solution. The mineral acid we use here, H2SO4. Should keep on adding until you get a dark blue coloration. So we almost got. Okay. So keep on adding dropwise until you get this color. Fine. Now all the mineral acid is removed. Now what is the next step? We have to add 1 test tube of dilute acetic acid. And why are we adding this dilute acetic acid? Dilute acetic acid is added to remove the excess of the ammonia added and to provide slightly acidic medium. We are adding acetic acid to remove the excess of ammonia added and to provide slightly acidic medium. Here the question asked will be, can we add any strong acids like HCl or HNO3? Okay, the answer is no. Okay, we should not add any strong acids like either HCl, HNO3 or H2SO4. We can add only the weak acid like the weak acetic acid only. Okay, otherwise it will oxidize. Okay, so we should not supposed to add the strong acids here. Okay, next step is important. We have to add here 1 test tube of 10% potassium iodide. Okay, after once when you add the potassium iodide, immediately you have to titrate against the standard sodium thiosulfate taken. Otherwise, if you add K and if you keep aside for some time, all the iodine liberated will be expelling out. Okay, so as soon as the K is added, you have to immediately titrate. Okay, so add K, you will be getting yellowish brown color like this. This is yellowish brown color. Now titrate to get a light yellow color. Titrate until you get light yellow color, and then we need to add the indicator. See, the color is becoming lighter. Okay, you should add carefully. If you add more, it will become here itself white color. Okay, this much is enough. This is light yellow color. Now at this stage, you have to add few drops of starch indicator. Okay, when you add starch indicator, the solution will become dark blue color. Add few drops of a starch indicator. Okay, once again titrate to get a clear white precipitation. That is the end point. Once again titrate to get white PPT. We got it. This is the end point. If any unreacted iodine is there, you may get recolored once again. So just add few drops. You will be getting clear white precipitation. This is the end point. We are getting white precipitation because of the formation of a Q plus iodide. This is about the titration. Okay, and I got the value of around 12.3. Okay, so you have to do 3 trials like this. 3 trials you have to do. First trial, okay, final current reading 12.3. Initial reading must be, you know very well, 0. Okay, so the volume of thiosulfate consumed is 12.3. And for other calculations, any one you have to take, whether you have got a concordant values or different, you should never take the average, take